Hi, we're on to video 6 now of the exponential and logarithmic functions video series. We're looking at the derivative of the log function now. So the basic result that we're following is that when we've got y equals log to the base e x, then the derivative of that is a 1 on the top and an x on the bottom. So notice that the x is our function we're talking about here. So it goes down the bottom, and the derivative of that x is on the top. So that's the general pattern, but we move fairly quickly straight to a more useful example, really. And that's the function of a function rule. A bit like what we said just then, even if this isn't an x and it's some more complicated function, it ends up down the bottom in the differentiated version with the differentiation of it on the top. So the top is the differentiation of the bottom. So when we're taking the derivative of a log base e function, the top is the derivative of the bottom. So when we have this example here, log to the base e x squared plus 5x, our answer will be an arrangement whereby, rather than equals, I'll say y dash equals, the top is the differentiation of the bottom. Now I may as well put this function down the bottom straight out because it's going into the bottom section straight from there. Now I'll take the derivative of that and put it on the top. So the derivative of x squared plus 5x is 2x plus 5. And we're done. There are more complicated versions than that, but that's the basic idea. The function comes down and is on the bottom, and the top is the derivative of that bottom in the differentiated version. Now we have quite a process in this one. First of all, it's pretty complex, this section here. We've got a fraction, we've got x's on top, x's on the bottom, and we've got to find the first derivative here. Now step 1, we're going to remind ourselves of the idea from log law 2 that if we're taking the log of something and there's a division involved, we can write it separately as a subtraction. So I'll do that now and then we'll chat in a moment. So you'll notice I've written it out here separately. We've got log e of the top minus log e of the bottom. And that's from log law 2 that we saw from a previous video. Alrighty, so that's just a rearrangement of y. We haven't started taking the derivative yet, but still. Now when we do, y dash is equal to, and we'll just concentrate on this first part first here. When we have the derivative, finding the derivative of a log e expression, we have the actual function on the bottom, and the top is the differentiation of it. So the bottom is x plus 1. The differentiation of x plus 1 is just 1, so we pop that on the top. So let's have a look at this second section now. As I said, the differentiation of a log e function. The bottom is just the function itself, 3x minus 4, and the top is the differentiation of that, which in this case is a 3. So that's our derivative. We're putting it in that arrangement whereby the top is the derivative of the bottom. Now this is a subtraction of two fractions here. I'll fast forward to some simplification of that in a second and explain it to you. What I've done there is I've made the bottom of my fraction here a product of these two, like you would with any subtraction of fractions. You've got to get the same bottom. And then I've done to the top whatever I did to the bottom. On the bottom here, I multiplied by 3x minus 4, so I must do the same to the top. On the bottom on the right-hand side, I multiplied by x plus 1, so I've got to do the same to the top there. So that's kind of two steps in one, but you'll get the idea, I'm sure. We'll expand the top, and I'll show you how that turns out. When we expand the top, we can expand here and carefully expand minus 3 times x minus 3 times 1, and we get that on the top. Now we can collect like terms a little bit on the top. Matter of fact, the 3x and the minus 3x cancel each other out, and we just get minus 7 over x plus 1, 3x minus 4 for our final answer. That's as simplified as we're going to get there. Okay, kind of tricky, but anyway, we've found and learnt from this video that when we're trying to take the derivative of a log e expression, we get the top being the derivative of the bottom, and we can also combine that particular phenomenon with other log laws where necessary to help us make it a bit simpler. So tricky little topic that, but you'll get the hang of it with enough practice. Thanks.